All right, I'm going to go ahead and talk through the next section. The next section incorporates some of this adding and subtracting as well. Okay, so you'll get a little more review on here. If you still have questions, you'll see it done a couple more times here in addition to some other things. Okay, so here's the last part of this chapter. Okay, it's complex fractions. That means it's a fraction within a fraction. Okay, so they're very complicated to look at, right, but you just need to approach it very systematically. There's two different methods that you can use on this. You can use either method with any type of problem, but there's some properties of certain problems that make them probably more or better suited to solve using one method over the other. Okay, this first method, and I just refer to them as method 1 and method 2. Okay, method 1 is going to involve reducing the numerator of the entire fraction, this whole thing, into one single fraction. And then do the same with this. Rewrite this bottom, the denominator of the whole fraction, as a single fraction. Again, using the process for adding and subtracting that we just talked about. And then instead of dividing them, what is division equivalent to? Multiply by the reciprocal. So then you'll take the top one and then you'll multiply it by the reciprocal of the bottom. Okay, so this is method 1. If you use method 1, the way that, or the method 1 tends to work better when you have a bunch of different denominators. And so here you have a denominator with a factor of x plus 2x plus 1, x plus 1, there's a repeated one, and then x. You have 3 different denominators here. Since there's 3 different factors in the denominator, oftentimes the method 1 will work more efficiently. Okay, but if I were to rewrite this numerator into one single fraction, what would my LCD have to be? An x plus 2 as well as a x plus 1. Here's my LCD for the numerator. So what I'm going to do is I'm going to take my given numerator, leave a space, my other given numerator, leave a space. And what we're going to do is multiply this numerator by the missing LCD factor. So what LCD factor was missing from this denominator? It has the x plus 2, it's missing the x plus 1. And then we take this x minus 1 and multiply it by the missing LCD factor from its denominator. What LCD factor is missing there? It has the x plus 1. This one is missing the x plus 2. Okay. So if I continue to work with this, and I'm just going to work with this fraction right here. Okay. And again, the denominator is not going to change. So what I'm going to do is FOIL to combine all my like terms here. So I get an x squared. Take my outer plus inner. I have 1x minus 2x gives me a negative x. Take my last, and I get a negative 2. So all I did there was FOIL. Going to do the same thing with the second set. My first is plus x squared. My outer plus inner gives me 2x minus 1x, so a plus x. And then my last gives me 2 times, a negative 1, so negative 2. So now, again, just working with this numerator, I'm going to combine my like terms. I have 2x squareds. My x's cancel, and I have a minus 4. So here is my numerator. It's all over x plus 2 times x plus 1. So what I've done right here is I've rewritten this numerator into a single fraction. Now I'm going to do the same thing with the denominator. So here I'll switch colors. Okay, I'm going to do that right below here. So when I combine my denominator into one single fraction, my LCD is going to have a factor of x plus 1. Also a factor of x. I'm going to write that first. Again, monomials, binomials, then trinomials, kind of in that order is how factors are usually written. So I'm going to take the numerator of my first fraction, leave a space. Take the numerator of my second fraction, leave a space. And I'm going to figure out what do I have to multiply these by to condense this into a single fraction. So I take this numerator times the missing LCD factor. Well, what factor was missing from this denominator? It has the x plus 1, it's missing the x. And then this second factor's numerator times what LCD factor was missing from its denominator, the x plus 1. Okay. So once again, I'm going to just work in my numerators. I'm going to combine everything. So here I just have to multiply, x squared. Here I have minus. Be very careful with your signs in this. We're going to subtract every single term that's being combined in this foiling. So if we FOIL this, we get a 2x squared. Our outer plus inner, we get 2x minus 3x gives us a negative x. And then our last term, negative 3 times 1, is negative 3. And then my final step is to distribute this negative here. So I have an x squared minus 2x squared minus a negative, so plus x, minus a negative, plus 3. And then the final step is to combine my like terms right here. So I get a negative x squared plus x plus 3. So here is my numerator, simplified. And then my denominator, I have x times x plus 1. All right, so I've rewritten my denominator as this single fraction, rewritten my numerator as this single fraction. So now instead of dividing, I'm going to multiply by the reciprocal. So let's completely factor everything that we can. What do you notice about this numerator up here? What can we factor out? So if we factor out a 2, we're left with 2 times the quantity x squared minus 2. And then we're going to multiply by the reciprocal of this. So we have our x times x plus 1. We invert it. So what was the denominator down here becomes the numerator up here. And then in this numerator, again, how do I want factors to be written? Leading coefficient of positive. So what do I need to factor out of each of these terms? So let's factor out a negative. And I'm going to get an x squared minus an x minus a 3. And now I can look to see, do any of these factors cancel out? Okay. So if I go through, I have x plus 1s. Those cancel. There's nothing else that cancels. So when I write my answer, I'm also going to move this negative. Remember, negative signs can be moved to the top, to the bottom, or out front. I'm just going to move it up to the top because now I have a negative 2x. And then I have this x squared minus 2. So there's my factors in the numerator. In the denominator, I have an x plus 2. And I have an x squared minus x minus 3. Okay, again, I've written my binomial before my trinomial factor. Okay, now, did we cancel any factors from the denominator? Here's a factor from the denominator that got canceled, so we have to exclude that value of x. What do we know x cannot be based on this canceled factor? Can't be a negative 1. Is there anything else that we need to take into consideration? Okay, let's look back at the original. Remember, anytime you're dividing, you have to look back at the original form. The original form, x can't be a negative 2. That's shown. X can't be a negative 1. We identified that. X can't be a negative 1. Again, identified. X can't be a 0. Is that shown in this simplified form? No, so we need to include that as a restriction as well. All right, so you can see this problem right here kind of incorporated every single thing that we've done so far in this chapter as well as a little bit from the previous chapter.